Hi everyone, there's a nice problem today from functions. It's the beginning of functional equations. I'm going to shoot other videos for the future. The first problem was also nice. We have function f whose domain is natural numbers and the range is r, as you see here. So f1 is 1010. For any natural number n equal greater than 2, f of 1, f of 2, f of 3 up to f of n, there's sum equal to n squared times f of n. If so, find f of 2021. Choosing 2021 actually I have to say is just, for the sake of the year. So that's why I've chosen number 2021. Okay, let's solve the problem. Okay, let's now first work on the relation here. So as you know, we can write, for example, square here like, just without even writing, find a square, n squared here. We know that if we choose n2, because we don't need to choose n1, it's already now as a value. So it will be for n2, it will be just f1 plus f2, which is equal to n. I just chose n squared, so 2 squared times f2. We'll get it carefully. We see that a is 3 times f2, because it will be 2 squared will be 4, 4 minus 1 is 3. It's 3 times f of 2 equal f of 1. So, you may think now already about, just find the value of f2, but don't jump on the just answer, just find the relation here. Okay, we found that actually f2 is 1 over 3 times f1. Okay, fine, nice. That's nice. Okay, let's try for n3. So if I just write for n3, I will get what? So it will be just f of 1 plus f of 2 plus, let me just separate this part, plus f of 3 equal, again, I've chosen n3. That means here I will plug 3 squared times f, and again f3. So if we look at carefully, we see that 9 here, 1 here. It will be 8. 8 times f of 3 will be equal f1 plus f2. So we know actually what f of 2 is. F of 2 is a third times f of 1. Okay? So it can be written like f of 1 plus f of 1 plus. Instead of f2, if I write 1 over 3 times f of 1, it will be 3, like here's 3, as you see guys, it's 3, okay, it's 3 and 4, f1, so I want to bring it here to show you. So f3 will be just, if I just simplify, f3 will be 1 over 6 f1. Okay, so fine. So I already found f3. So we need that f2 is, let's write the value of f of 2. It is 1 over 3 f1. So okay, fine. Let me erase this simplification here to continue finding other values, because if I just kind of create the relation, I can, in that case, assume the possible step forward to generalizing the given relation here. Okay, let me erase this part. So I just checked the values for n2, n3. Now let's check now values for n4, n5, n6. But I think it will be enough after those values. It will be enough to be able to say anything about how f of n, the function, actually behaves itself. Okay. So if n4, it will be just f1 plus, as you see here, plus f2, f3. Plus f4, so equal n squared f4. It will be, n is 4, 4 squared 16. We can just write 16 f4. So here 1, 16, it will be just 15 when subtracting. Okay, it will 15 times f of 4 equal f1, f2, f3, and f3. Their sum. So we have f1. We also have f2, which is a third times f of 1. Plus, we also have f3, which is 1 over 6 f of 1. If we keep, simplifying, it will be just 6 here. 6 to 8, 1, 9, f1. So if I just keep simplifying, I cancel by 3. 2 is 3, 3, 15, 5. So, okay, f of 4 will be 1 over 10. Okay, fine. So I also found f of 4. So you may think, okay, finding this value will get us what? Because, and up to which step it should continue. Okay, but actually we already feel the relation here. So it's n4, now let's continue and try n5. Found that n4 is 1 over 10. So I think n4 and 6 can be better assistance. Can aid us better, I think, because those even just finding 7 or 8. So as long as we go further, we will see that if we just can notice the actual fact that there is a picture being opened step by step. Okay, by just finding the values here. Okay, let's explore f05, probably f06, maybe, yeah, also. Okay, f05. So before, let me just erase first. Okay, so if we just plug here n5, so it will be f1 plus f02, f03, f04, f05, and as I plug n5, it will be 5 squared. So 5 squared means 25. 25 f05, because here also the same thing. So 1 f05, 25 f05. So it means it will be 24. Okay, 24 times f05 will be equal to the sum of the first 4 terms. We know the values actually then. So we know f1 is f1. So we have found that f2 is nothing but 1 over 3 f01. So f3 is 1 over 6 f1. 1 over 4, 1 over 10 f1. So if we simplify, okay, we can see that it is, just 30 is a common denominator. 30 plus 10, 40, 40 plus 45, and 48. 48 times f01. Okay, so by just 8, 6 here, 3 here, and just 2, just 2 and 15, yeah. So f05 will essentially be, let me write here, f05 will be 1 over 15 f01. Okay, so actually we already feel that. Now let me find 6 and then later open the second here. Okay, just take it here. Okay, if you got it, I think we knew that f05 is 1 over 15 f01. So let me raise to find the value of f06, because f06 or f07, those values are already, let's say, key values. So f06, if n6, it will be f01, f2, f just 5 up to 5, equal, plus f6, equal n6, n36, 36, f06. So 1 here, 36 here. It means 35 because just it will come here and we will just subtract one value. Okay, it will be 35 times f06 equal. So f1, which is f1, of course we know the value, but we don't need to plug in because plugging the value will exacerbate the situation. So f2 is nothing but 1 over 3 times f1, and so f3 1 over 6, f4 1 over 10, and f5 1 over 15. So okay, so if we just keep simplifying, it is common denominator again 30. It will be 30 plus 10 here, 5 here, as you see, 5. Then okay, 10, 5, 3, and finally 2. So it and times f01. Okay, so it will be 40, 45, 5, 50. So we just 50 over 30 times f01. But don't forget that there is 35. Okay, if we simplify, it will be just 5, 3, and by 5, 7 here. So we will see that f of 6 is nothing but 1 over 7, 3, 21 f01. Okay, so I think we should stop here already. So you may now, raise a question. Okay, we stop here, but we seem not to have got anything yet. But actually we have. So if we go to 6, that's not, because I will now put the values and open the explore. Actually, I will reveal the secret here. If you upload the coded, that's nice. Guys, look at the here values. So F1 is, we don't just pay attention to just F1. We begin with F2. But let's look at the here coefficient. F2 is, if you look at it, it is 1 over 3 F1. Okay, fine. So F3 can be written like this. 3 can be written like this. 1 plus 2 times F1. Okay? So it is the sum of the first two numbers. Consecutive, actually. Yeah, that's fine. So let's look at F3. F3 is 1 over 6 F1. It is 1, 2, 3 times F1. So the sum of the first 3 consecutive natural numbers. 1, 3, just 1, 2, 3. Okay, fine. So F4, if you look at carefully, you see that it is 1 over 10 F1. So, okay, it will be just 1 plus 2 plus 3 plus 4. The first 4. Okay, so in this way, we'll see that 15 can also be written 1 plus 2 plus 3, 4, 5, first 5. So 21 will be written first 6. So, okay, so this number here in the argument shows the number of the values, the sum of the number of the values that are summed in the denominator. That's fine. So if we generalize the point, actually we can write like this: Fn. So Fn f of n. So it can be, arguably believed to be 1 over 1 plus 2 plus 3 n times f of 1. Here's our relation. That's perfect relation. Actually, we found that f of n is equal to 1 over the sum of the first n natural numbers from 1 to, of course, to n times f of 1. So just plug in the values of 1, 2, 3, 4, actually beginning from 2. So you will just get different values. Some values will already found together. Okay? So we need to find f 2021. So that means we have to plug 2021. So where we receive n. Okay, let's do. If n 2021. Let me read this part because we already solved a nice problem. So we will see that 2021, f of 2021 will be 1 over 1 plus 2 plus 3 up to 2021 times f1. f1 is this value. That's all. Actually, you can go further and calculate it if you want, but that's the result, or you can leave it here. Okay? So I think we should better calculate it, but it will not be something great, but okay. So it will 1 over 1 plus, so the number of the 2 will come here, 2 here, 2021 times 2021 times 1000. It's kind of answer. If you want, you can also, simplify more. So I think that's enough. This is the result, but here what I tried to show you was to understand the approach and to just create background for the questions that first just look unreasonable, look to have promised nothing. But when we try to do something, we actually see that there is the point that we can do. Okay, that's the result. You can simplify. You can just choose other values to simplify and find and be happy. That's the result. See you guys.